Hello, so greetings of the day. Today we are going to look onto the research topic of sequential pattern mining on web server logs using PrefixSpan. Before we get into anything, what is server log? So when you refresh a web page, you obviously send request to it, right? So the server, they receive the requests and they send the files in return. So it can be text file or images file or say whatever. Now these files, its information is stored in a text format in a text file. So these are called server logs. Basically, it keeps a track of what the server is doing at what point of time. So the heart of this research is simple that we are going to be simply exploring the byproduct of internet architecture, which is the web server log. Now, every HTTP request made to a web server, like let it be Apache or engines, they generate a log entry. As I said, it keeps a track of what all has been requested from the server and what has been completed. Right. So these entries contain IP addresses, timestamps, the get or post method, the URL that had been requested, and all the stuff. Now, what is the point exactly? So these are all are raw logs. Okay, they are very raw, and the thing is, they are very noisy. They can contain those informations which are not needed, and uh, so if a single person logs into a web page, it can maybe trigger even 20 entries at a time. So because there are many files, right? CSS, JavaScript, image files, text files, sometimes even uh, sound files and all. So and the thing is, HTTP is a stateless protocol. The server simply sees everything discrete and isolated requests. It does not natively group these requests into a user journey. So these are all the caveats which you are facing, right? So as I said, the raw data problem of scale and okay, I think I didn't say the missing link. So uh, when the people navigate, there is always a link that scales from one page to another. So that can also be exposed. So it's about the link. Now, let's see, why does warehousing become essential into it? So the thing is, you cannot simply run advanced mining algorithms on raw text files, right? So that is where data warehousing and mining is a very necessary foundation for it. First of all, you go through the basic but a very rigorous ETL process, which is extract, transform, and load. So first, what you do, data cleaning, right? So you filter out the traffic, the error codes, and the static requests, so that because images and all, only it will be known that only it has been requested but not the content of image, so we don't need that actually. So that will be filtered out, only the meaningful content of the pages remain. Then the sessions are very crucial. So when an individual clicks are grouped into user sessions, the algorithms group requests by IP address or session cookies with a particular threshold. So it varies. Sometimes 30 minutes of inactivity or 15 minutes of inactivity means the session has been ended. Now the loading, the structured sessions which we have sorted by far are loaded into data warehouse and are created into a highly organized sequence database ready for query computation and all. So this is where actually data warehousing comes into place. Now, what is sequential pattern mining? We know the title, but what exactly it is? So let's have a look onto that too. So, you know, once the database is built after all the filtered logs we have got, it is very, very, very important to distinguish the sequential mining, pattern mining from the association rule mining, like what we have done, like a priori algorithm to find item sets that co-occur, buying a bread and buying a butter together. So the order does not matter over there, but in SPM, which is sequential pattern mining, the dimension of the time is absolute. So we are looking for sequential relationships. Uh, how do I explain? Okay, you can say that if event event 2 occurs, does it occur after event 1? So this is one important rule which is not there in a priori. You can say like a kind of a conditional probability, right? So the goal is to find subsequences that actually appear frequently across all user sessions. So there should be a minimum threshold, for example, 30% or 40%. Only then the algorithm will return the paths of at least 40% of the users, right? Um, so why not the normal sequential pattern? Why is it that we are using a special pattern? So the thing is, first, candidate generation. So first of all, let's see how GSP works, which is generalized sequential pattern works. First, GSP generates and test methodology. So it works on that. It looks for frequent one item sequences and then joins them to generate candidates for two item sequences. And then say for three item, four item, and so on. Now, what is the flaw in it? The candidate generation is very it can be said that it's too big, it's too catastrophic for big data. So suppose a website has 1,000 frequent single pages, the GSP might first generate 1,000 into 1,000, which is 1 million. 1 million candidate two item sequences, then it holds these in the memory, which is too much of traffic for that particular memory, and then constantly scanning them in data warehouses. So this increases the memory usage very significantly. So what are we doing along with the sequential mining pattern? We are including prefix span. So yes, so this is the solution. So how are we going to do this? Is that first let's understand what is prefix span. Right. So finding actually, okay, the term itself, prefix, meaning until what we have done till now. That is what is prefix, not after. So considering everything we have done till now. So prefix span actually solves the sequential pattern, the disadvantage by completely eliminating the candidate generation step. Instead, it uses the very famous divide and conquer approach. So, how it works theoretically is that first it finds frequent prefixes. It can scans the database once to find all the frequent single items. So, say, if home page is frequent, home page becomes our first prefix. Then create a projected database. So, for every frequent prefix, the algorithm creates a projected database. It looks at the main database, finds every session where the user has visited the home page, and extracts only the sequence of events that has happened after that visit. So, uh, and then recursive growth, right? So the prefix span that recursively mines this new, much smaller projected database to find the next frequent item. For example, let's say the product page. The sequence grows to home page and product. So it's like that. And the project database is projected again, shrinking further. So by creating such projected databases, the prefix span constantly shrinks the search space. It never generates meaningless candidates. It looks at the sequences that actually exist in the data. This drastically lowers the RAM consumption and accelerates processing speed. So, yeah, so this is how I did it. Right. So this is the complete mining pipeline which we have gone through as of now. So first image collection and then pre-processing and then data warehouse integration and then prefix span. Now, how do we turn this into action is that uh, we have all these, but is it practically applicable? So let's see that if the prefix span model knows that the sequence, like for example, home page and the product page, has a 95% support rate. For those who don't know, support rate means it's a threshold that they go along well. So if this happens, this happens, right? The server can proactively prefetch and cache. The thing is about cache. So if it's known that it's to be visited, it is already stored in the memory so that you don't have to scan the entire database again, right? The server can proactively prefetch and cache the dashboard HTML into RAM the moment the user hits the login page. This achieves a very less latency and the balances server loads. The UI UX redesign, if the mind patterns show the constantly looping between search page and the product page or the checkout page without ever reaching the help page, the developers have empirical proof of a bad user interface and can restructure the site flow. That will help in an organized way of it. Now the dynamic personalization is by analyzing a user's real-time click stream. So how the person is actually interacting and where is he visiting in the web page and matching it against the previous prefix span patterns so that the site can predict their next move and can serve the recommendations before they click smoothly, right? So this is how we are doing it, and the future scope is uh, even though we focus on the historical data to try to predict the future actions of the user, the integrating prefix span concepts with streamlining uh, tools like Apache or Kafka would allow for the live injection of web logs, right? Enabling the system to predict user journeys and adapt the website state in real time rather than strictly relying on batch processed data. So that is something which we have to improvise on. So yeah, that's it. Thank you.